So what is software-defined perimeter? Well, the first sentence of Wikipedia says it's also called a black cloud, and it is an approach to computer security which evolved from the work done at the Defense Information Systems Agency. So this work being done at DISA was under the Global Information Grid Black Core Network Initiative around 2007. So seeing how much flack the NSA gets in the tech world for the things they do, I'm thinking DISA here gets a little ignored. I mean, they created this thing called the Black Cloud. But anyways, the Global Information Grid, aka GIG, if you didn't know about it, it supports all DoD national security and related intelligence community missions and functions strategic, operational, tactical, and businesses, both in war and peace. But I don't want to get into GIG, I want to get into SDP. In this paragraph, they start by saying connectivity is based on a need-to-know model. This fits nicely into that zero trust concept. And over here, the reason things work the way they do in the Black Cloud is because they're trying to mitigate attacks. And the first word they say here, server scanning, that's not necessarily an attack. It can lead to an attack. But SDP stops the ability for someone to do server scanning. And then, of course, denial of service. At first, I thought this model was just all about stopping people from doing lateral movements within the network, but in the end, it looks like its primary attack it's stopping is DOS attacks. So there's that denial of service. It'll stop or mitigate SQL injections, operating system and application vulnerability exploits, man-in-the-middle, cross-site scripting, cross-site request forgery, pass the hash, pass the ticket, and other attacks by unauthorized users. That's a little verbose. Maybe they could have just stopped that sentence right there. Here it says there was an open source implementation done, paid by Homeland Security. So somebody go over to Wikipedia and fix that grammatical error. But I did follow those citations, and I'll take you there now, or I'll take you to one of them now. Looks like there was an error with my link, but here we go with client and gateway modules for software-defined perimeters. Here's the README, and maybe I will go into this at another date, in another video. I love when they have tutorials like this. But let's get back to the primary article here. Just know there's implementations of software-defined perimeters that are open source. So I think that's pretty good for the security community. Now, when reading about the background of SDP, I found a helpful vocab term here, traditional fixed perimeters. So that's the opposite of what an SDP is. And as you continue to read right here, this reminded me of something I heard on the podcast Beers with Talos recently. Someone on that podcast said NAT, or Network Address Translation, is the greatest security tool around. And if you think about it, is NAT helping protect internal services from external threats via simple techniques for blocking visibility and accessibility? And I would say yeah. And yeah, this is becoming an ever more problematic thing in our society. It's problematic because of the increased popularity of user-managed devices and phishing attacks. You need no skill to execute a phishing attack. Nowadays, people are rampantly providing untrusted access inside their perimeter. And what are some clouds doing? Not the Black Cloud, right? Some clouds are simply extending that perimeter. So thus, software-defined perimeters address these issues by giving application owners the ability to deploy perimeters that retain the traditional model's value of invisibility and inaccessibility to outsiders. And I don't know if I'm correct at all in this thinking, but after all this research, it really just sounds like an SDP is the establishment of a very well-secured private network, but it's still a private network. This picture does a great job of showing us the difference between maybe your traditional TCP/IP network and an SDP one. Here, you can connect and then you authenticate. In order to even get into the opportunity to connect to somewhere in a SDP, you would first authenticate. And that's what's making me think like this is just a well-secured private network. Maybe it's a big network, but still, using quotations, private. Now to get into the architecture of SDP, you have yourself hosts and controllers. The host can initiate the connections or accept connections. These types of actions are managed by the controllers. And I think it's worth noting right here that the control plane is separated from the data plane to enable greater scalability. So these black clouds can be large. And if we make those nodes in the network redundant, we can have higher availability. So those black clouds can be like benefiting from the reputation regular clouds have right now. So you need an SDP controller to manage authentication and authorization services. Now you have lots of choices, right? You would look into the implementation of this to figure out what's going on. You could use PKI, device fingerprinting, geolocation, SAML, OpenID. Any of these can be used. Pick your favorite. They can be used in this black cloud. And I think this part about controllers determining which hosts are brought online after you authenticate really gives this cloud a lot of security, because you have just so much control over that. Not to mention the optional policies that you can use or click on establish in order to require encryption for those communications. So that's the basic architecture. We can now go into the SDP deployment models. You have one called client to gateway. The benefits of this is you could mitigate common lateral movement attacks such as server scanning, OS and application vulnerability exploits. Right, if they can't scan, they won't know what operating systems are there, and thus maybe have a harder time exploiting those. But the client to gateway model will also mitigate password cracking, man in the middle, pass the hash, and others. So a good way to remember this client to gateway model is think of that song War. What is it good for? Absolutely nothing. I'm not going to sing to you guys, but just think of that. Client to gateway, what is it good for? Mitigate common lateral movement attacks such as server scanning, and then you just think of the entire list. Sorry, I have no musical talent. The next model is client to server. This is usually based on the number of servers being protected, your load balancing methodology, and the elasticity of those servers. Next is the server to server model of SDP. Here, servers can offer a representational state transfer service, a simple object access protocol service, a remote procedure call, or just any kind of programming interface, API, right, over the internet. If you're authorized, of course, you can utilize these services. Now, our next model is just complicated. It's client to client. You'll see this with IP telephones, chat, and video conferencing. Another model opposed to this one is the client to gateway to client configuration. And why would you use this one? Well, to hide the application server as well. So let's talk about SDP applications. SDP is good for hiding those enterprise applications and isolating them. As I said before, I think I'm mistaken in thinking that black clouds are all about stopping lateral movement. I think they're more about denial of services. But that's a summary of the whole article. The summary of this paragraph is right here, that unauthorized users will not have network access to the protected application, so thus mitigating the lateral movement these attacks depend on. I thought it was pretty genius here where they say SDPs can be used by enterprise to hide and secure their public cloud instances in isolation, or as a unified system that includes private and public cloud instances and or cross-cloud clusters. So we all know cloud computing is big, and it's also getting big in the government, which means so is cloud security. This paragraph right here is just a tease. They don't really tell us very much. See if I could do research and watch a video of somebody walking me through the process of this all right here. And then look at that. How witty is this? SDP as a service. And by the way, they mixed up the order here. So first they want to talk about SaaS, then IaaS, and then platform as a service. Here's a nice visual in case you forgot the difference between those three. But this is the end of the video. I hope you feel better about this term, software-defined perimeter. And if you don't, in the next video, I'll go over the differences between SDP and SDN. Software-defined network is a term that might have been around a little bit longer than SDP.